name is Ana Sofia González Chavira, and I am going to talk about NoSQL database management systems. So let's begin by talking about MongoDB. So what is MongoDB? In short, MongoDB is a NoSQL database, document-oriented. What does it mean? Documented means that it uses relationships between documents instead of tables, like a relational database would be. It allows us to save a big quantity of documents in a distributed way. These documents can take any structure we want. They don't necessarily have to be the same or even similar to one another. While a relational database avoids redundancy, a NoSQL database such as MongoDB appraises it and uses it to work in a much more flexible and scalable way. Alright, so now I'm going to talk about the main characteristics of MongoDB. To start, MongoDB has a distributed database. It means that MongoDB not only needs one server, it can use as many as it needs. This leads to Mongo to be a lot more scalable. It's perfect for projects that need to grow really fast. Next is that it doesn't need a predefined schema. What does it mean? With a relational database, we would need to worry about having the database completely functional and working and ready before the project sets off. This doesn't happen with MongoDB. With MongoDB, we can make the database, make the whole work while we're working on the project. We don't need to worry about having it all ready before we begin. Next thing is that it works in a BSON format. This format is really similar to a JSON format. It allows us to work in a document-oriented way, which is another of the main characteristics of MongoDB. Next thing with MongoDB are the pros and cons of it. Let's begin with the pros. First of all, MongoDB has no predefined schema as mentioned before. This is a huge pro. It makes a very dynamic schematic architecture for unstructured data. It allows you to have objects in one collection that have different sets of fields. This flexibility may become very useful when using real-world data which require constant changes. Next is its syntax. MongoDB syntax is probably one of the main reasons why it has become really popular. Unlike an SQL database, with Mongo, it has a much more easier and readable syntax by using JSON documents, like shown before. MongoDB also has the characteristic that its data structures may be accessed through any programming language that is native to it. Next is the fast performance. Instead of storing and grabbing data from the hard disk, MongoDB stores it and grabs it directly from the RAM. This makes the process obviously a lot more faster. MongoDB also allows you to break the database in different parts, which in a relational database would probably be represented with tons of different tables. So next up are the cons. As everything besides the good things, MongoDB has some cons that should be considered before we implement it to an application. Something that should be mentioned is that if the application we want to develop requires transactions, it probably shouldn't use MongoDB since it doesn't support them. And trying to use it may put our data or data for users at risk, making it a lot more sensible to corruption. Something else that could be a potential risk are duplicates. Next up are the MongoDB makes joins and indexing, as mentioned before, very hard. This may put the data to risk and it may be more susceptible to its duplication again. When is MongoDB recommended for a project? MongoDB has been proven to be very useful for most modern applications, especially ones that require constant changes. Due to its certain cons that mentioned before, it is necessary to make sure we consider certain aspects before we decide if we will be using it. Some instances in which MongoDB can be an improvement for our application would be a block for content management. Due to MongoDB flaws with management of sensible data, a block could be excellent to manage through it. It isn't a constant change, obviously. A block receives a lot of data. It's probably a project that will grow also with time because, again, it is a constant changing. We need to update a block constantly. This makes Mongo a perfect option because of its flexibility and the performance. Next up would be a project which would need analytics. Most projects, especially the ones made up for enterprises, will probably require analytics to keep track of user logs or who enters, who does what, etc. Once again, analytics require constant changes and flexibility since it would grow bigger with time. Next up would be localization. Any application that requires geolocation of its users could use MongoDB to manage this information. Again, it is in constant change and it is propped to grow bigger and bigger with time. Now that we're done talking about theory and stuff, we will move to the code. So now we can begin by creating a new cluster on MongoDB. We have to start by logging into our account. In my case, I'm going to use my Google account. Once that is done, we can see right here we don't have any databases, we don't have any clusters, so we can just click here to begin. In our case, since we don't have any money, we're going to click on the free option. We can select if either we want a provider from Amazon Web Services, Google Cloud, or Azure. I'm going to choose Google Cloud on Iowa. And we can name our cluster. In my case, I'm just going to name it DB Remedial or something. And create cluster. So now to create a new collection, I just have to click here on collection and add my own data. In this case, I'm going to do a database of zoo, and the collection name is going to be limos. So now right here I have my collection, I have my database right here, and I can insert a document here on animals. This is the ID. I can give it a name like one. Type is gonna be a penguin. Food, I don't know, fish. And environment, cold. And now I have a new document with my new animal, who's a penguin named Juan. I can also add another one like name, Juana, type, lion, food, meat, environment, savannah, or hot, I don't know, hot weather. Insert, and there it is. I have my two animals right here. Alright, so now I'm going to begin by connecting MongoDB with my current project. I'm going to begin by adding my IP address. I'm going to use my current IP address, confirm. And I'm going to add a new user, which will be me. It's going to be admin, and I'll to generate a secure password. And I'm going to add the user. Now if I go to databases, I can already see my cluster here is ready. I just have to click here on connect. The connection security setup is already done, which is it's what I just did. Now I can connect to my application, Python version 3.6 or later, and I have to copy this. Now that information, I am gonna paste it right here. The point of having this admin and password is that I have, well, we're supposed to write here our admin and our password, but in order to avoid doing that, we can just add that information here. For the moment, right here, I'm just gonna put some necessary imports from flask by mongo import by mongo and import os, and I'm going to create some variables which are the ones I'm going to be using here but are going to be like from here. So for that I'm just going to write nope, not there, here, os dot get emb and db user, which is the name of the variable that I will make here in a moment. Then db password for the password, os.get emb db password, and last db name, nope, os.get emb db name. Alright. Alright, so now that that is done, I can begin creating the necessary variables here. So I start by writing flask app main.py, and then flask debug equals 1. It looks better, nope, like this, nope, there. Flask debug and flask emb, that's not correct, flask emb development. And everything else is basically this stuff, but instead of osmb, I just have to write the information that I recently made on MongoDB. So I can move to MongoDB. You cannot see it because I can only show one screen at a time, but I just have to write right here. Database name, DB, remedial, user, it was admin, and the password, which I will write in a second. The password, which is this, and those would be the necessary environment variables that we are going to use. Another thing missing right here, I forgot to add the variables here in the URL. I just have to write f, and here instead of admin I write db user, and password db password. Yes. Alright, so now to begin with the actual part of coding and all that, I'm going to click right here and I'm going to make a new request collection on Insomnia. This one is going to be called db remedial. And what I'm going to do here is I'm going to add necessary requests I'm going to use. In this case, I have to use a CRUD, so I need to make first CRUD. This stands for create, so I'm going to make a post. It's based on a zoo, on animals, so I'm just going to add an animal to the zoo. Then we have read, it's a get, get an animal, create. Then update, which would be put, edit an animal info, create, and delete. Remove an animal from the zoo. Right, so these are going to be the requests I'm going to use. Now I need to move to the code to start creating the endpoints. Right, so on this part, what I have to do first is that I have to change this name of test. I have to change it to zoo. Why? Because this is the name of the database I made on MongoDB. This is going to work as a variable that I'm going to use here on main.py, and it's going to access to this database, which is soup. Okay, so now I'm going to begin in the main.py file. For now, since these are really simple thing. I'm just gonna work on this file. I'm gonna start by adding the necessary imports, which is from flask, import flask, JSONify, and request from flask RESTful import API resource rig parse and abort. What else? From flask by mongo import by mongo. Import db config from no and the database, which is import db config as database. This right here is this file. It's going to include everything we have right here. What else do I need? From bzone JSON util import dumps and object ID. Alright, so these are the imports I'm going to use. This is incorrect. There it is. This right here is for the ID. It's going to save the ID as an object. Next, I need to add this app flask name, no, and API app. What is this? That is going to create an instance for the API. And if name, as always in Python, equals to main, then app.run load.env true. What does this do? This is going to run practically the project, and the next line, app.run, is going to get the information from the .env file. So now that this is ready, I can test if it is working right now. It's a really simple test. It's basically nothing, but I can test it on the console. Alright, so here in the console, what I have to do first is activate the virtual environment, bnb, scripts, activate, and I just have to run py main.py just to make sure everything is working for now. And the server is up with Flask app. For now, everything is okay. Okay, so now let's begin making the first endpoint. This import had to be commented because it was breaking the application. What do we have to do first? We have to make a new class, which is going to be animal. We're just going to be working with one animal at a time, so it's animal, not animal. And this resource which comes from this import. Then we have to make a new function, which is going to be post. What is post? Well, to make a new animal. We're going to work with the ID that comes automatically thanks to MongoDB and database.db.animals.insert1. Very self-explanatory. Accesses to the database, which is here. Then from here it goes to DB, which is this. Inside of SUI, if you remember, we have animals. And we're going to insert just one. What is next? We have to add the information that we are going to add now. And we had the name. And to access to add the information, we have to work with JSON. So we're going to request.json and name, because this is the information we want to access, so we can add it. And we had for which were name and then type and food and environment. food environment. One thing missing here is that now we have to add here inserted ID. Not like that, like this. Inserted ID, which helps us to insert this information. We're going to add a return message so that when we are working under Insomnia, we can know this has worked properly. And it can be something simple like your animal was added to the zoo. Yay. Okay. Then we have to add a new URL so we can access through it. And for that, we have to write api.add resource, which resource we want to access, animal. And the link, I guess, could be new. Okay, so now we can go to Insomnia to test this. Right, so now here on Insomnia, I can start testing what I just did. To do that, I have to run the application just like I did before on the console. And I'm going to get a message that says running on a URL, which is a local host. Then I have to add new, which is what I added on my code. Body, JSON. And right here is where I'm going to add the information of each animal. Name, and then it was type, no. What else? Food and environment. Name, I don't know, Juanito. Type, it's going to be a bear. Food, fish, I think. Environment, hot. And if I click here, I get a message. Your animal was added to the zoo, which means it worked correctly. Okay, so what is next? We already have the create. Now we need to use read. So for this, I'm going to create a new class, which is going to be called animals, again, resource. And I'm going to get a new endpoint, which is going to get, I want to make an endpoint that retrieves all animals in the zoo. For this, I need to add a response list because it's a list, and this same thing as before to be animals, but instead of we insert one, find, then for doc in response, you are going to doc id equals string doc id. This to retrieve all of the documents, meaning animals in the database. And another response, which is going to be return JSONify response. What else? I need to add another URL, but here instead of animal, it's going to be all animals, and instead of new, all, so I can get my full list of my animals. Now back to Insomnia. I had this get an animal, but this is going to be to get a specific animal, but I don't want that now. I want to get all animals. Here I can practically use this same link, but instead of new, it's going to be all. And if I click here and send, I get information of all my animals. These are the ones I made directly on MongoDB. This is the one I just made. Right, so now I'm going to add a new function, which is going to be another get. But instead of getting all animals, I just wanted to retrieve one animal depending on the information we're going to send to it. But before I do that, I want to add another thing, which is abort if not exist. And what is this going to do? Basically, it's going to look for that thing we are looking for. And if it doesn't find it, it's going to return 404 error. Yes. Then if by and data, this is by and this is data. If by equals to ID, then the response database dot to be animals find one, because it's just going to get one animal. That's why we're working on animal and not animals. Find one ID object ID data. You can see now that I uncommented this because we're going to need this. Else response database.db.animals.find one, and right here it's going to look for this data. First, it's going to see if it's an ID. If it's not, it means it's any of this other stuff. Then if response exists, if this was correct, then just return the response. If not, it means that doesn't exist, so it's going to abort. JSONify, and we're getting a status error, which is 404, which means it doesn't exist or it wasn't found by f data not found. This is not correct because this doesn't go here. There. If we get a response, we will return the response. If not, it's going to send a message, which is status 404, ID or name or type or whatever. This data was not found. Next, now that this is ready, I'm going to add the get function I was talking about. Def get self by and data. As explained before, this is name and this is data. Response is going to be self dot abort if not exists by and data. Right. The response here is going to come from this, because this is going to happen first in order to check if what we are looking for is actually there. Response ID str response ID. Alright, and then we get our response, which is not response, it's return JSONify response. Alright, this is going to look for a specific thing. But before we do that, we need to add here something else to this URL. Here it's going to look for something, but how are we going to send what we're looking for with this? Which is going to be, what was it like? It was a string by points string data. This URL is going to be string by, it's going to be a word, either one of these or even the ID, then 2 points, this points, and data, which is going to be basically the name or the type or the ID or whatever. Now we can test it on Insomnia. Okay, so now I'm here on Insomnia. I'm going to use this URL, but I'm going to change it. As explained before, here's going to be name. I can see here name and Juan. I'm going to see if it works by looking for Juan. name, 2 points, and 1. Send. And I get a response, which is Juan the penguin, which is right here. So now that I can access to just one element, I can use that to proceed to the next thing. We have the create, we have the read. Now we need to do the update. So it's going to be dev put self by and data. No. And once again, response is going to come from here because it has to check if what we're looking for exists. Self abort if not exists by in data, that is correct. For key and value in request.json.items. What is it going to do? It's going to be response key value. What is this? It's going to look for the elements inside the JSON request. Then we're going to access to the database once again, database db animals and update 1. ID object ID once again, response no ID. Okay, then it's going to go here, I believe. Here it's going to use set like this. Set once again. What is set? It's going to look for the element before it edits it. And here's basically the same as here. I can just copy and paste it. This difference is instead of request JSON, it's going to be response. Response, and response. And that is correct, but this has a really ugly syntax. That looks better. Then right here, what is going to be the response? It's going to get the ID, and it's basically going to retrieve the element we just edited. ID return JSONify response. Okay, that is correct. We don't need to add another URL. We can work with this one. Now we can move to Insomnia again to edit one animal. So now here in Insomnia, as I said before, I can use this same URL here. Maybe instead of looking for name, I'm going to look by ID. I'm going to use Juanito right now. ID 1. And I can check if this URL works right here. There is. JSON. Here I just have to add, it's really similar to post, but I just have to add the information I want to edit. This is Juanito. Now his name is going to be Juanete. Not like that. Nice. And there it is. Now his name is Juanete. If I get here all animals, now he's Juanete. Now back to the code. Last but not least, we got to create, we got to read, update. We're missing the D, which stands for delete. Dev was delete, just the same. Self, by, and data. And again, response comes from abort if not exist. And database.db.animals delete 1. And it's going to get the ID, response, ID. Yep, and response, ID, the string response and ID, and it's going to return chase. Oh no, animal was successfully transferred because deleting it's too cruel. Okay, once again, it's going to be similar to put because it's going to use this. It's going to look for an animal and it's going to move it to another zoo. In other words, it's going to delete it. Okay, so now I'm going to delete an animal. I'm just going to use this one because I already have it. Just have to put the URL, and if I send it, animal was successfully transferred to another zoo and it was deleted from our database. And we can check right here, Juanete is gone forever. So now we see before it works correctly, we can test it all together. Now I'm going to create a new animal. His name is going to be, I don't know, Jose is going to be an elephant. Elephant is going to get grass, environment hot. Animal was added to the zoo. We can check that. Here it is, Jose. Get an animal. We can get it, I don't know, let's see by the foot. And he eats grass. Here it is. He eats this. We can change this. Nope. Now instead of, no, his name was Jose. Now he is going to be, oops, Josefina. Josefina is there. Josefina. You can remove, oh no, I think it would be better by using the ID. Animal was transferred. Josefina is gone. Alright, everything works. We got the C, we got the R, we got the U, and we got the T.